There are 10 million billion of them inside your body right now, a number so large that it's almost meaningless to the human mind, and they are producing roughly your entire body weight in ATP, the molecule that powers every single biological process you perform every single day. They aren't organs, they aren't systems, and they aren't something your doctor checks at your annual physical. They're called mitochondria. They live inside virtually every cell you have, and they are the reason you're alive, because without the energy they produce, your heart couldn't beat, your lungs couldn't expand, your brain couldn't fire a single thought, and every cell in your body would shut down within minutes. And here's what nobody tells you at your doctor's office, even though the research community has known it for over a decade. Mitochondrial function declines with age, and not gradually, not gently, but substantially. By the time you're in your 60s, estimates suggest that your mitochondria are producing somewhere between 30 and 50% less energy than they did at their peak. And the waste products they generate in the process of making that reduced energy, reactive oxygen species, also known as free radicals, have increased in proportion, creating a double hit where you have less fuel and more damage happening simultaneously. This decline is now recognized by the aging research community as one of the central driving mechanisms behind virtually every major disease of aging, from heart failure to Alzheimer's, to cancer, to diabetes, to the generalized fatigue and weakness that most people assume is simply what getting old feels like. But mitochondrial shutdown doesn't announce itself with a diagnosis. It announces itself with symptoms, 8 of them, that are so common, so easily dismissed, and so frequently attributed to other causes that most people live with them for years without ever realizing that the real problem is happening inside their cells at a level too small to see, but too consequential to ignore. Here's how to recognize them. Symptom number 1 is a fatigue that goes beyond tired, a deep cellular exhaustion that sleep doesn't resolve and rest doesn't fix. This is the hallmark symptom of mitochondrial decline, and it's the one that affects virtually everyone whose mitochondria are underperforming. When your cells can't produce enough ATP to meet the energy demands of daily life, getting out of bed, walking across a room, concentrating on a conversation, digesting a meal, the deficit doesn't show up as a specific pain or a localized problem. It shows up as an all-encompassing heaviness, a sense that everything requires more effort than it should, a feeling that your battery starts the day at 60% instead of 100 and drops from there. This isn't laziness, it isn't depression in most cases, and it isn't just aging. It's an energy production crisis at the cellular level, and it's the most direct and most universal consequence of mitochondria that are running below capacity. Symptom number 2 is exercise intolerance, the inability to sustain physical activity at levels you once handled easily. Your skeletal muscles contain more mitochondria per cell than almost any other tissue in the body, heart muscle being the notable exception, because muscle contraction is one of the most energy-intensive activities your cells perform. When those mitochondria lose efficiency, the first thing you notice is that physical activities that used to feel manageable now feel disproportionately difficult. Climbing stairs leaves you winded. Walking a distance that never bothered you now requires a rest stop, and a recovery after any exertion takes noticeably longer than it used to. This isn't the normal reduction in fitness that comes from being less active. It's a cellular energy supply problem where the muscles are willing, but the power plants inside them literally cannot generate ATP fast enough to sustain the contraction. Symptom number 3 is brain fog, difficulty concentrating, and a mental sharpness that seems to dim without explanation. The brain consumes roughly 20% of your body's total energy output, despite comprising only 2% of your body weight, making it the most energy-hungry organ per gram that you possess. And that means it's also the organ most sensitive to any decline in mitochondrial output. When your brain's mitochondria produce less ATP, the neurons fire more slowly, the synaptic connections that underpin focus and memory function less efficiently, and the neurochemical balance that governs clear thinking, or the production and regulation of acetylcholine, dopamine, norepinephrine, and serotonin, becomes impaired because every step of neurotransmitter synthesis and release requires ATP. The result is the collection of cognitive symptoms that people over 60 describe as brain fog, difficulty finding words, trouble holding a thought, a sense that your mental clarity has been replaced by a soft haze that seems to thicken with every passing year. Symptom number 4 is increased sensitivity to cold, particularly in the hands and feet. Mitochondria generate heat as a natural byproduct of ATP production. It's one of the reasons your body maintains a core temperature of 98.6 degrees even when the air around you is much cooler. When mitochondrial output drops, heat production drops with it, and the body responds by prioritizing heat delivery to core organs and reducing blood flow to the extremities. The result is hands and feet that feel cold more easily, more often, and more intensely than they used to, a symptom that most people blame on poor circulation or Raynaud's phenomenon, without ever considering that the fundamental heat-generating capacity of their cells has diminished because the organelles responsible for producing that heat are no longer functioning at full power. Symptom number 5 is muscle weakness that progresses independently of how much exercise you do. This goes beyond the exercise intolerance we discussed in symptom 2. It's a progressive loss of muscle strength and mass that occurs even in people who are staying active and working out regularly. When the mitochondria inside muscle satellite cells, the stem cells responsible for muscle repair and growth, are dysfunctional, those stem cells can't produce enough energy to divide, differentiate, and fuse with existing muscle fibers the way they need to. The muscle receives the stimulus from exercise but can't complete the repair and growth response, so strength stagnates or declines despite consistent effort. This pattern, working out but not getting stronger or even getting weaker over time, is one of the most frustrating and most specific signs of mitochondrial dysfunction in skeletal muscle. Symptom number 6 is digestive problems that seem to have no clear cause. The smooth muscle cells lining your digestive tract, the cells responsible for the rhythmic contractions called peristalsis that move food through your stomach, small intestine, and colon, are heavily dependent on mitochondrial energy to maintain their contractile function. And when those mitochondria underperform, peristalsis slows, food moves through the digestive system more sluggishly, and the result is bloating, constipation, a feeling of fullness that lasts longer than it should after eating, and a general sense that your digestion has become less efficient without any obvious dietary explanation. Many people over 60 develop these symptoms gradually and attribute them to food sensitivities, aging, or irritable bowel syndrome without ever considering that the motility of their gut, the physical movement of food through the tract, is being limited by an energy deficit in the smooth muscle cells that make it happen. Symptom number 7 is mood changes, particularly increased anxiety, irritability, or depressive flatness that doesn't match your circumstances. Neurotransmitter production is one of the most ATP-dependent processes in the brain, and when mitochondrial output in neurons and glial cells declines, the synthesis and release of serotonin, dopamine, GABA, and norepinephrine are all affected, not dramatically enough to cause a diagnosable psychiatric condition in most cases, but enough to shift your emotional baseline in ways that feel real and persistent. The joy you used to feel from activities that once excited you dims slightly. Your patience shortens for no clear reason. A low-grade anxiety hums in the background of your day without any obvious trigger, and flatness settles over your mood that isn't quite depression, but isn't the emotional vibrancy you remember either. These shifts are subtle, but they're consistent with what mitochondrial researchers observe in models of cellular energy depletion. and they often improve when mitochondrial function is supported through the nutritional strategies we've discussed in previous videos. And symptom number 8 is poor sleep quality, particularly difficulty staying asleep through the night despite feeling exhausted. This seems paradoxical. If your cells are tired, why can't you sleep? The answer lies in the fact that sleep is not a passive process. It's an active, highly energy-demanding state during which your brain performs critical maintenance functions, including memory consolidation, metabolic waste clearance through the lymphatic system, and cellular repair. When mitochondria in the brain can't produce enough ATP to power these nighttime functions efficiently, the sleep architecture becomes disrupted. You may fall asleep initially because you're exhausted, but you wake repeatedly during the night because the brain can't sustain the deep restorative stages of sleep that require the most energy. The result is a cruel cycle. Mitochondrial dysfunction causes fatigue. The fatigue makes you crave sleep, but the same dysfunction prevents you from getting the deep sleep that would allow your cells to repair themselves, which worsens the mitochondrial dysfunction further. Here's what connects all 8 of these symptoms into a single coherent picture, and what separates mitochondrial decline from the dozens of other conditions that can cause similar complaints. The key is the pattern. When fatigue, exercise intolerance, brain fog, cold sensitivity, muscle weakness, digestive sluggishness, mood flatness, and disrupted sleep all show up together, worsening gradually over months or years without any single diagnosis explaining the full picture, the common denominator isn't 8 separate problems. It's one problem, insufficient cellular energy that manifesting in 8 different organ systems that all depend on the same fuel source. And the solutions are not mysterious. They're the same mitochondria supporting foods and nutrients we've covered across this channel: omega-3s for membrane integrity, CoQ10 for electron transport, B vitamins for NAD plus production, magnesium for ATP activation, pomegranate for mitophagy-driven cleanup of damaged mitochondria, beets for nitric oxide enhanced efficiency, and the antioxidant-rich diet that protects the mitochondria from the oxidative damage that started this cascade in the first place. Your mitochondria aren't dead. They're depleted, damaged, and desperately waiting for the molecular support they need to start producing energy at the level your body requires. Give it to them, and these 8 symptoms don't have to be your new normal. Share this with someone who's been feeling all of these things and blaming it on age. Subscribe so you don't miss what's coming next. And as always, take care of yourselves. I'll see you in the next one.